I want to find the derivative of tan inverse of x here, so I'm gonna assume that we know the derivative of tan, which we know from previous units and stuff like that. And then I'm gonna go through and just use some of the ideas that we know actually from way back when in geometry. So I don't know the derivative of tan inverse, but I do know the derivative of tan. So the first thing I'm gonna do is write that tan of I don't like this. That tan of y is equal to x. And I know that's true because I can take the tan inverse of both, or the tan of both sides here. If I take the tan of this, I get tan of y. If I take the tan of this, well, tan and tan inverse cancel and give me x out. So the next thing that I do is I derive with respect to x. Sometimes it helps me see with implicit differentiation like this that I need to do chain rule on y if I put that piece there. So the derivative of the tan gives me a y prime times secant squared of y. And then the derivative of the right-hand side, well, that's x, so the derivative of the right-hand side is just 1. From here, I can divide both sides by secant squared and get y prime equals 1 over secant squared y. But I don't like to have those types of trig functions in denominators or anything like that. So I'm going to change that over to a cosine squared because 1 over cosine squared is secant squared. Or 1 over cosine is secant, so 1 over secant is cosine. So I can change this over to y prime equal to so I get this y prime equals cosine squared of y. So from here, this, when you look at this equation, I'm going to do a couple things. I'm going to use this to evaluate this thing. That bottom line right there that I underlined, the cosine squared y, it's no good to, or at least in this case, for me to have a formula for the derivative of tan, because I'm looking for y is tan x, right? And this says, all right, well, y prime is cosine squared of y. Well, it doesn't do me any good. I want to know what y prime is in terms of x, right? Because I want to have, like, you know, if I give you the derivative of sine x, well, its derivative, if y is sine x, then its derivative is cosine of x. So I want to have x's over on this right side. Anyway, so I'm going to use this to turn this into x's. So to do that, if I'm taking the sine, cosine, or tan of something, in this case a y, then that something is usually an angle. So I'm going to draw a triangle like this, and I'm going to label that angle y. Then, what's tan? Well, we go back to geometry. Tan is opposite over adjacent for whatever this angle is right here. So if I have x is equal to O over A, then I could write that as x over 1 and not change this thing. So what I can do is make the opposite side of y x and make the adjacent side to y 1. Then I use Pythagorean theorem, and I find that the hypotenuse is square root of this, is square root of this squared plus this squared. So I get square root of 1 plus x squared. And you could write it the other way around, but I know what I'm setting myself up for, so I'm going to write it like that. What I mean is you could write the x squared first and then the plus 1. So, you'd be like, well, why do we do that? Well, here I'm asking for cosine squared. We'll go in blue. Here I'm asking for cosine squared of y, or I'm trying to find cosine squared of y. I know that that's what y prime is equal to. So I know that y prime is equal to cosine squared of y. Well, that is O squared, or sorry, I'll make that an A, adjacent squared over hypotenuse squared. And that's just using stuff from trig way back when. So what's the adjacent side? Well, it's 1. So I get adjacent squared, 1 squared is 1, over what's the hypotenuse? Well, it's this. So I square that, and it just cancels out the square root. So I get 1 plus x squared. So I'm pretty much done here at this point. I started with y equal to tan inverse. I wanted to find y prime. I wanted to find it in terms of x, this variable. So I did some stuff with I wrote it in a way that I could derive the equation. I used implicit differentiation to derive it. I solved, I simplified for y. Then I took this thing, I drew this triangle based on that information, and then I evaluated what this was based on that triangle. So I get to this thing, I get to this thing. So based on this, I've now connected y prime to this, right? So, and this is what y is, so I can connect everything and say, well, therefore I know that tan inverse of x prime is equal to this thing, which is 1 over 1 plus x squared.